Alright, we're in great shape so far. We've connected to our source data, and we've built out our entire data model, relationships, hierarchies, everything. But there's still limited in terms of the metrics or quantitative values that we can analyze here, like shipped quantity and order quantity. So in this section, we're going to focus on Power BI's formula language, DAX, and use it to create brand new calculated columns and measures that expand the kinds of insights we can produce. So, what is DAX? DAX stands for Data Analysis Expressions, and it was originally modeled after Excel's formula language. The idea behind this was simple. Business users were already comfortable with Excel, so using a familiar syntax made DAX easier to learn and adopt. If you're used to nesting functions in Excel, you'll feel right at home nesting functions in DAX. We use DAX to express business logic inside the data model. For example, calculating gross profit margin, year-over-year growth, and other custom KPIs. There are two main ways DAX is applied in Power BI. One is calculated columns. Calculated columns live inside your tables and are computed row by row. They create a physical column in the data model, which means they do take up storage space. You'll typically use calculated columns in dimension tables, where they can serve as labels, grouping fields, or slicers in a report. Another is measures. Measures are aggregations, calculations performed at query time. They do not take up space in the data model, and their values are dynamically evaluated based on the filters in your visuals. While measures often appear in fact tables, they technically belong to the overall model, which means their names must be unique across the entire dataset. Now let's talk a little bit about DAX syntax. Look at a simple example, the sum function, and break it into parts. Starting from the left, we have the measure name as total quantity. When you reference a measure in a formula, it will always appear in brackets, so having spaces in the name is totally fine. The next component is the function name. This appears immediately after the equals sign. Here's a key distinction. Calculated columns can use a naked reference, meaning they can point directly to a column without aggregating it. That works because the calculation is performed row by row. Measures cannot use naked column references. If you try to define a measure as just orders, shipped quantity, Power BI won't know how to turn that into a single value, so it returns an error. Measures must use an aggregation like sum, average, min, max, and so on. Then there are table and column names. This makes up the final part of the expression. A table name followed by a column name is a fully qualified column reference. If the table name contains spaces, it must be wrapped in single quotes. A quick tip. Use fully qualified names for columns, but just a name when referencing measures. It keeps your formulas clean and makes them easier to read. Now let's move on to common DAX operators. Most DAX operators are familiar, including arithmetic operators of addition, subtraction, multiplication, division, and exponents. Comparison operators of equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. Where things get slightly different is with text and logical operators. Text concatenation. The AND operator combines values into a single text string. Logical operators. Double and means AND. Double vertical bar symbol means OR. There's also the AND operator, which creates a logical OR condition based on a list contained in curly brackets. Wrapping up. In today's lesson, we introduced DAX, explored the two main ways to use it, and walked through core DAX syntax and operators. In the next video, we'll start creating calculated columns and measures so we can bring our data model to life. Thanks so much for watching, and don't forget to subscribe to the channel to support our work and stay updated on all upcoming lessons.